let's talk a little bit about inheritance. When you're in your beginning programming courses, you learn the typical this class inherits from that class, and it inherits its functionality and it inherits its data members, but we really don't think of it as what it really is. And in C++, or at least in game programming, when we're managing our own memory and things that we'll do down the road, you better be sure you understand exactly what a class means and what inheritance means and what happens when you inherit and all the caveats that go along with it. Um, what's nice about learning object-oriented programming early in your life is you can think of code as objects, and it's nice because we're used to objects in real life being physical things we can touch or interact with, and and they have properties about them, and they have functionality, and they can interact, and that's great. And so you translate that to code, and it just makes sense. But then you forget that there's really actually bytes and memory behind this, and you need to be aware of that, and we will be throughout the time that we use C++. But anyway, so let's get down to it. Let's do class base, just because I can't think of anything more interesting to do. I'm going to make an int, first int, and another int, second int, two ints, cout, size of base, two ints, 4 bytes, 4 plus 4 bytes should make 8 bytes. Very good, 8 bytes. So then let's make a class that inherits from base. So class, let's call it derived, and we inherit from base. And in C++, this is the syntax for inheritance, is the colon. The public thing I'm not even going to get into. Just type public there, always and forever. If you can type private and other kind of things, and it has different semantics, but it's just dumb. I don't know why they put it in there. It's just lame. I've never had need of it, and blah 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 blah. Just say public. If you want to Google the other things you can do there and what they mean, go for it. I'm sure there's plenty of religious holy wars out there regarding what should be there. But for me, say public, and that's it. Keep it simple. So let's say int derived member. Ooh, this is getting better. Int another derived member, and let's say just this derived just likes to really load it up. So the size of a base. So if we look at a base, it's still two ints, and two ints is 4 bytes plus 4 bytes. Still makes 8 bytes. That's nice. So when we say size of derived, if you're naive, you'll say, oh, well, it has 3 ints. And an int plus an int plus an int is 4 bytes plus 4 bytes plus 4 bytes, so 3 times 4. So the size of derived should be 12. If you're not naive, though, you'll remember, oh, a derived inherits base, which means it inherits these two elements as well, which would make an additional 8 bytes. So 12 plus 8 is 20 bytes total. And one way you can think of inheritance, the semantics aren't perfect here, but you could think of inheritance as derived just essentially doing this, and we say derived. You could think of it that way, and when you do think of it that way, it makes sense. Well, now I have 1, 2, 3, 4, 5 ints, 4 bytes each. 4 bytes times 5 int, or 5 variables is 20 bytes, which we still get 20 bytes. So anyway, there's a section in your book, page. If I look here, page 93. It shows a little bit about the memory layout there in the diagram, showing that basically, if we go back to our original setup, the base fields here, or data members, take up the first 8 bytes of an instance on the stack or heap or wherever this thing exists, and then the next 3 members are below it sequentially, whatever that means in your memory layout. So that's inheritance in a nutshell, at least as far as size and memory layout goes.